Okay, this is Algebra 1, Section 4, scatter plots and lines of best fit. It's on page 247. All right, so we're going to discuss data today, and data, how we put data in, and graph it, and things like that. And so we're talking about bivariate data. Bivariate data, bi means two, so we're talking basically about coordinates. X, Y coordinates. Okay, so we're talking about points that have X, Y data. All right? And what we're going to do is we're going to graph data in what we call a scatter plot form. A scatter plot form. Can you read that? Am I running out of? I'm not sure what color to use. We'll try blue. See if it helps. See if you can read it. Okay. So let me give you an example. All right. We're only going to use positive numbers, so we're only going to be in the first quadrant if you think about the coordinate plane. But we're going to talk about plotting points, so something like this, okay? Just at random points, and you'll be given that, and you'll have to look at and decide what to do with it. Okay, this is called a scatter plot. Okay, now if you look at this scatter plot, the points as we go left to right are going up, right? This is what we call a positive correlation. Okay, now your book calls it an association also, but we very seldom, I don't know that I've ever heard an association, but it is a positive correlation because as we go this way, the points are going up, okay? All right, now if we look at this one might be something like this, okay? This one is a negative correlation. And because as we go this way, the points are going down. Does that look right to you? Now, there is this one too. If we have points like this is no correlation because we really can't tell. Okay? All right? Questions about that? So you need to know the different types of correlation that are involved. All right? So on page 248, if you're following along, we have lines of fit. Okay? And lines of fit is what happens when we take points, we make a scatter plot, we determine the relationship that is happening. Okay? Now, these two have what we call a linear relationship. Which means that we could form a line, and I'll use a different color, we could form a line, and I didn't use a straight edge, but that would be halfway between the points. Do you see that? So half of the points are on this side and half of the points are on that side. Now, Tyro, when we find this line, we need to pick 2 points because 2 points determine a line. Okay? And what we want to do is we want to pick them so that basically half the points are on one side, half the points are on the other. Do not spend all day on this. Okay? We simply look for 2 points that we could draw a line through. Okay? Now I can't do it to this one because it really doesn't have a linear correlation. Now, what is the advantage of this? Finding a linear correlation. Well, a linear correlation is if we can find a line that fits it, we can predict data inside the data and outside the data. I'm going to talk about that in a minute. But once we have the line drawn with the 2 points, then we use the 2 lines to find an equation for it, and then we use the line to make predictions. Okay? Let's take an example here. All right? We're going to talk about this one right here on your worksheet. And you might have trouble reading mine, so you might have to read yours. In the first one, it says the scatter plot shows the number of CDs in millions that were sold from 1999 to 2005. If the trends continue, about how many CDs were sold in 2006? Do you see 2006 on the chart? No. Okay. So I'm going to bring this up now. If the data we're looking for, if the prediction that we're looking for is inside the data, this is called linear interpolation. And I'll spell this for you after I write it. Interpolation is I-N-T-E-R-P-O-L-A-T-I-O-N. So this is not what we're finding in this particular one. In this particular one, 2006 is outside the graph. So that is not linear interpolation. Do you understand that, Chuck? Because 2006 is not inside the graph. Okay? So what we're finding is a prediction that is outside the data. And this is called, oh, I forgot linear there. Linear extrapolation. And I'll spell it for you because this doesn't do it justice. Okay? So it's E-X-T-R-A-P-O-L-A-T-I-O-N. All right? Questions? All right. All right, so this is what we're going to do. We're going to, I'm going to cover this up, but okay, so if you get your worksheet, we'll go ahead and start this. I'm going to put it up here. Okay, the first thing is that we want to draw a best fit line, and I'm going to help you on this first one. They chose this point right here. See this point right here? I don't know if I can get any thinner. See this point right here? They chose that one, and they chose this one. Now, it is a coincidence that they chose the first and the last point. You don't always choose the first and the last point. Do you understand that? Okay, you might choose one in here. For example, they might have chose this one and this one. Or they might have chose this one and this one. Is it possible that Ryan Lords choose a different point than Allie? Is that possible? Yes. Will they get different answers? Well, you're going to think they're different because they're going to look different. But Jackson, I'm going to tell you that they're going to be very similar, but they're going to look different. Okay, so we're going to choose this point and this point. I also want you to look at this. What is this little break here? What is that telling me? That's telling me that they jumped on the y-axis from 0 to 650. That there's a break in the y's. If the break was here, it would be a break on the x's too. Now you'll notice that the x's are in years, aren't they? And the y's are in millions. So this scatter plot shows the number of CDs in millions that were sold from 1999 to 2005. Now this is an old question because we don't use CDs anymore, do we? They're pretty obsolete. Okay, so what point is this? Write that coordinate plane down. What point is that? Well, the x value is what? 99. Well, and we can't use 99 but this would be the first year. This would be the second year. Oh, we could use 1999, but we got to use the whole year. Let's use the whole year. So this is 1999 is the x. And what's the y approximately? 940. So everybody, we're going to use 1999, comma 940. All right, let's go over here. What's this point? Ashley? The x is what? This point right here. What's the x? 2005. 2005, and what's the y? Be what? Isn't that right on the line? 700. Don't use what I'm showing you. Okay. All right, so let's talk then. All right, give me those 2 points again. This is number one. Number one, what were the 2 points? It was, what, 1999? 940 and 700. Okay. All right. Now what we want to find is an equation. This is called a best fit line. That's the best fit line. We want to find an equation of that line. So what do we find? We have 2 points. So what do we find first? You should know this from the quiz. What do we find first?
Slope.
Slope. Change in y over change in x, right? Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So slope is, all right, I'm going to take 940 minus 700, and then I'm going to take 1999 minus 2005. Okay, on the top, what do I get? 240, and on the bottom, what do we get? -6. Now, I believe that 240 divided by -6 is a -40. Is that correct? Yes or no? All right, folks. Are we good, Jackson? You understand everything up to that?
Yep.
All right. So now we need an equation, right? So we want to use point slope form. Y minus y sub 1 equals m times x minus x sub 1. All right, which point do we use? Either one. I'm going to use this one. I like those numbers better. But Chuck, you can use this one if you want. So I'm going to go y minus what, Chuck? 700 equals my slope, which is -40, times x minus what? What do I put in there? Caden? 2005. All right. So now this is going to be big numbers, right? This is going to be y plus a -700 equals a -40x, and this is plus a negative. What is, and it's positive, what is 40 times 2005? 80,200. Do you agree? 80,200. So I'm going to go over here if you don't mind. I'm running out of room. Okay? So now I have y plus a -700 equals a -40x plus 80,200. Do we agree with the 80,200? I didn't do it, so I want to make sure we're right on that. Yes? Okay. So now we're going to subtract the -700 from both sides, which is the same as adding it, right? Right?
Yes.
We're going to add it. So I get y equals a -40x plus 80,900, right? All right, now folks, this is what we call the equation of they call it a line of fit. I call it a best fit line. It's named both ways, best fit line or best line of fit. Okay? Any questions? All right. Now the question was, remember the question? We're going to run out of room here. The question says, if the trend continued, about how many CDs were sold in 2006? We got to plug it in for X. All right, so we want to go Y equals, and I don't have a lot of room here, so negative 40 times 2006 plus 80,900. So what does Y equal? Use a calculator. What did we get? How much, Tara? 660. Now, 660 what? Well, first of all, let's see if that makes sense. Okay? I think this one says about 650. But yeah, it makes sense because it would be down here, wouldn't it? So it's going down, right? So it would be down here. Okay, so they got about, so why did they get a different answer? They did used a different point, didn't they? Okay, so about 660 what? CDs. Not just CDs. Million CDs. Okay, million CDs. Okay? Caden, do you have a problem? Are you okay? You act like you have a question.
Negative 40
times 2006.
2006.
Yeah.
Where is 640? Oh wait, no, subtract. Wait.
Where did the 640 come from?
Or not the 660.
Okay, so she took this times this and added it to 80,900. It's negative. So a negative 40. I don't know if I can.
So that's
40 times 2,000. I can't. My solar calculator's not working.
I have it.
Okay. All right. Okay. Do you get that? All right. Now let's take a look at the next one. Okay, it says, family. The table shows the predicted annual cost for a middle income family to raise a child from birth until adulthood. Draw a scatter plot to describe the relationship that exists within the data. Okay, now, here's your points. All right, and you can see I've drawn this for you. I've kind of given you the benefit of the doubt. I better cover some of these up or you'd be copying them all. But if I do 3 and it's about 10,700, you'll notice there's another break in here. So 10,700, and then 6 and 11,700, 9, 12,600, 12, 15,000, and then 15 is about 16,700. Looking at this, the person that did this, right? It looks like they used this point, the 3 point, and the 12 point. And notice that's about right because we have one on this side and one on this side, and then these two are close, right? So it looks like they used this point and this point, okay? You could have probably used these 2 points too, right? But Chuck, I think they used 3 and 12, okay? So they used this point in the chart and this point, all right? And so then you do the same thing. You find the slope, and then you use one of those points to find an equation, and then you answer the question. Well, actually, it says draw a scatter plot and draw and describe what relationship exists. This is a positive relationship, isn't it, Chuck? It's a positive because from left to right, it's going up. Now, do we have to answer any other questions? That means as the child gets older, the cost to raise a child increases. Does that make sense? Tater, do you cost your parents more money than your little sister?
Probably.
Yes, you do, because you're involved in more things, right? You require more food, right? Okay, so what I want you to do is, this worksheet is due, what's today, Thursday? This worksheet is due Monday. So I'll give you today and tomorrow to work on it, okay? All right.